Backup targets. A wide range of technology solutions are currently available for backup targets. Tape and disk libraries are the most two commonly used backup targets. In the past, tape technology was a predominant target for backup due to its low cost. But performance and management limitations associated with tapes and the availability of low cost disk drives have made the disk a viable backup target. A virtual tape library is one of the options that uses disks as a backup medium. VTL emulates tapes and provides enhanced backup and recovery possibilities. Backup to tape. Tapes, a low cost solution, are used extensively for backup. Tape drives are used to read-write data from to a tape cartridge. Tape drives are referred to as sequential or linear access devices because the data is written or read sequentially. A tape cartridge is composed of magnetic tapes in a plastic enclosure. Tape mounting is the process of inserting a tape cartridge into a tape drive. The tape drive has motorized controls to move the magnetic tape around, enabling the head to read or write data. Several types of tape cartridges are available. They may vary in size, capacity, shape, density, tape length, tape thickness, tape tracks, and supported speed. Backup to tape, physical tape library. The physical tape library provides housing and power for a large number of tape drives and tape cartridges, along with a robotic arm or picker mechanism. The backup software has intelligence to manage the robotic arm and entire backup process. We have a figure to represent this physical tape library, which contains drives, cartridges, import-export mailbox, linear robotic system. Tape drives read and write data from and to a tape. Tape drives are placed in the slots when not in use by a tape drive. Robotic arms are used to move tapes between cartridge slots and tape drives. Mail or import-export slots are used to add or remove tapes from the library without opening the access door. When a backup process starts, the robotic arm is instructed to load a tape drive. This process adds delay to a degree depending on the type of hardware used, but it generally takes 5 to 10 seconds to mount a tape. After the tape is mounted, additional time is spent to position the heads and validate header information. This total time is called load to ready time, and it can vary from several seconds to minutes. The tape drive receives backup data and stores the data in its internal buffer. This backup data is then returned to the tape-in blocks. During this process, it is best to ensure that the tape drive is kept busy continuously to prevent gaps between the blocks. This is accomplished by buffering the data on tape drives. The speed of the tape drives can also be adjusted to match data transfer rates. Physical tape library. Tape drive streaming or multiple streaming writes data from multiple streams on a single tape to keep the drive busy. As shown in the below figure, multiple streaming improves media performance, but it has an associated disadvantage. The backup data is interleaved because data from multiple streams is written on it. Consequently, the data recovery is increased because all the extra data from the other streams must be read and discarded while recovering a single stream. Tape drive streaming or multiple streaming writes data from multiple streams on a single tape to keep the drive busy. As shown in the figure, multiple streaming improves media for performance, but it has associated disadvantage. The backup data is interleaved because data from multiple streams is written on it. Consequently, the data recovery time is increased because all the extra data from other streams must be read and discarded while recovering a single stream. Many times, even the buffering and speed adjustment features of a tape drive fail to prevent the caps, causing shoe shining effect or back hitching. Shoe shining is a repeated back and forth motion of a tape drive makes when there is an interruption in the backup data stream. For example, if a storage node sends data slower than the tape drive writes into the tape, the drive periodically stops and waits for the data to catch up. After the drive determines that there is enough data to start writing again, it rewinds to the exact place where the last write took place and continues. This repeated back and forth motion not only causes a degradation of service but also excess wear and tear to tapes. When the tape operation finishes, the tape rewinds to the starting position and it is unmounted. The robotic arm is then instructed to move the unmounted tape back to the slot. Rewind time can range from several seconds to minutes. When a restore is initiated, the backup software identifies which tapes are required. The robotic arm is instructed to move the tape from its slot to a tape drive. If the required tape is not found in the tape library, the backup software displays a message instructing the operator to manually insert the required tape in the tape library. When a file or group of files require restores, the tape must move to that particular file location sequentially before it can start reading. This process can take a significant amount of time, especially if the required files are recorded at the end of the tape. Modern tape devices have an indexing mechanism that enables a tape to be fast forwarded to a location near the required data. The tape drive then fine tunes the tape position to get to the data. However, before adopting a solution that uses this mechanism, one should consider the benefits of date streaming performance versus the cost of writing an index. Limitations of tape. Tape are primarily used for long-term offsite storage because of their low cost. Tapes must be stored in locations with a controlled environment to ensure preservation of the media and to prevent data corruption. Data access in a tape is sequential, which can slow backup and recovery operations. Tapes are highly susceptible to wear and tear and usually have shorter shelf time. Physical transportation of tapes to offsite location also adds to management overhead and increases the possibility of loss of tapes during offsite shipment. Because of increased availability, the low-cost discs have now replaced tapes as the primary device for storing backup data because of their performance advantage. Backup to disk system offers ease of implementation, reduced TCO and improved quality of service. Apart from performance benefits in terms of data transfer rates, disks also offer faster recovery when compared to tapes. Backing up to disk storage system offers clear advantages due to their inherent random access and RAID protection capabilities. In most backup environments, backup to disk is used as a staging area where the data is copied temporarily before transferring or staging into tapes. This enhances backup performance. Some backup products allow for backup images to remain on the disk for a period of time even after they have been staged. This enables a much faster restore. Below figure illustrates a recovery scenario comparing tape versus disk. As shown in the figure, as restore from disk took 24 minutes compared to the restore from a tape which took 108 minutes from the same environment. Recovering from a full backup copy stored on the disk and kept on site provides the fastest recovery solution. Using the disk enables the creation of full backups more frequently, which in turn improves RPO and RTO. Backup to disk does not offer any inherent offsite capability and is dependent on other technologies such as local and remote replication. In addition, some backup products require additional modules and licenses to support backup to disk, which may also require additional configuration steps including creation of RAID groups and file system tuning. These activities are not usually performed by backup administrator. Backup to virtual tape. Virtual tapes are described, emulated and presented as tapes to the backup software. The key benefit of using a virtual tape is that it does not require any additional modules, configuration or changes in the legacy backup software. This preserves the investment made in the backup software. Virtual tape library. A virtual tape library has the same components as that of a physical tape library, except that the majority of the components are presented as virtual resources. For the backup software, there is no difference between a physical tape library and a virtual tape library. We have a diagrammatic representation of virtual tape library where you have LAN, FCSAN, backup clients, backup server and virtual tape library application. Virtual tape libraries use disks as backup media. Emulation software has a database with a list of virtual tapes and each virtual tape is assigned space on a LAN. A virtual tape can span multiple LANs if required. File system awareness is not required when backing up because the virtual tape solution typically uses raw devices. Similar to a physical tape library, a robot mount is virtually performed when a backup process starts in the virtual tape library. However, unlike a physical tape library, where this process involves some mechanical delays, in a virtual tape library is almost instantaneous. Even the load to ready time is much less than in the physical tape library. After the virtual tape is mounted and the virtual tape drive is positioned, the virtual tape is ready to be used and backup data can be returned to it. In most cases, data is returned to the virtual tape immediately. Unlike a physical tape library, the virtual tape library is not constrained by the sequential access and also shoe shining effect. When the operation is complete, the backup software issues a rewind command. This rewind is also instantaneous. The virtual tape is then unmounted and the virtual robotic arm is instructed to move it back to a virtual slot. The steps to restore data are similar to those in a physical type library, but restore operation is nearly instantaneous. Even though virtual tapes are based on disks, which provide random access, they still emulate the tape behavior. A virtual tape library appliance offers a number of features that are not available with physical tape libraries. Some virtual tape libraries offer multiple emulation engines configured in an active cluster configuration. An engine is a dedicated server with a customized operating system that makes a physical disk in the VTL appears as tapes to the backup application. With this feature, one engine can pick up the virtual resource from another engine in the event of any failure and enable the clients to continue using their assigned virtual resources transparently. Backup to virtual tape. Data replication over IP is available with most of the virtual tape library applications. This feature enables virtual tapes to be replicated over an inexpensive internet protocol network to a remote site. As a result, organizations can comply with the off-site requirements for backup data. Connecting the engines of a virtual tape library appliance to a physical tape library enables the virtual tapes to be copied onto the physical tapes, which can then be sent to a vault or shipped to an off-site location. Using virtual tapes offers several advantages over both physical tapes and disks. Compared to physical tapes, virtual tapes offer better single stream performance, better reliability, and random disk access characteristics. Backup and restore operations benefit from the disk random access characteristics because they are always online and provide faster backup and recovery. A virtual tape drive does not require the usual maintenance tasks associated with a physical tape drive, such as periodic cleaning and drive calibration. Compared to backup to disk devices, a virtual tape library offers easy installation and administration because it is pre-configured by the manufacturer. However, a virtual tape library is generally used only for backup purposes. In a backup to disk environment, the disk system are used for both production and backup data. We have a backup target comparison with features tape, disk and virtual tape. The features are offsite replication capabilities, reliability, performance and use, which is compared to tape, disk and virtual tape.